So here we have example 11. It says suppose we have the following probability distribution for x, and here we have our distribution going from x going from 0 to 6, and our f of x 0 0.1, 0 0.2, 0 0.1, 0 0.3, 0 0.1, 0 0.2. Then it says draw a graph of the PMF and the CDF of x. Write down the CDF as the piecewise function. Alright. Now on the left side, we're going to start with the PMF of the graph. So here we have is f of x is equal to p of big X is equal to small x. Now we can draw the graph starting with the x-axis going from 0 to 6. That would be at our x. The y-axis can be represented as our f of x. 0 0.1, 0 0.2, 0 0.3, and 0 0.4. And then we start graphing it. So at 0 would be 0 0.1, at 1 it would be 0 0.2, at 2 it would be 0 0.1, at 3 it would be 0 0.3, at 4 it would be 0 0.1, and at 5 it would be 0, and then 6 would be 0 0.2. Now on the right side we will be drawing the CDF. So we have the x and the y, same thing. Now we can plot this going from 0 0.1 to 1. Okay. Mm, 0 0.8, 0 0.9, and then 1. And the x is the same thing, just 0 to 6. Now we can graph the CDF. So we would leave open that area. Yep, there we go. Notice how I'm having closed and open intervals. I will explain this shortly, but let me just graph it. So at 2 it would go up to 0 0.4, and then from 3 it would go to 0 0.7, close at 0 0.7. 4 it would be 0 0.9, and then 6 it would just be 1. Now we can see that's an increase of 0.1, that's an increase of 0.2, that's an increase of 0.1, that's an increase of 0.3, increase of 0.1, and increase of 0.2. Yep, right there. So for the CDF, we start off with our first x value, which is 0. So you can see that it is an open interval right here, and everything past that would be before 0. Now at 1, we start at 1.0. Going from 0 to 1, we have an increase of 0.1. That's why we have an increase of 0.1 right here. Open interval, closed. Now if you go up 0.2, which is right here, 0.2, it'd be a closed interval over here. Going right, it'd be an open interval at 2. Now this is an increase of 0.1 right here. This is a closed interval, open interval. This is an increase of 0.3 because right here if x is 3, then f of x would be 0.3, and if x is 4 right here, it would be an increase of 0.1 from 3 to 4, and we skip 5 because 5 is 0, and then from at x equals 6 we would have an open interval and a closed interval onward as 0.2, and then 6 and up it would just be 1. Now we can write the piecewise function. So that would be f of x is equal to, this is going to be very big. So first we can start off with 0. So 0 would be x is less than 0. 0.1 it would be 0 is less than or equal to x less than 1. 0.3 would be represented as 1 less than or equal to x less than 2. 0.4 would be 2 less than or equal to x less than 3. 0.7 is 3 less than or equal to x less than 4. 0.8 is for less than or equal to x less than 6, and then 1 is x is greater than or equal to x 6. We can also look at the last graph, the CDF graph, for an example of representation of how the piecewise function actually works. Now we can move on to example 12, where suppose we have the following distribution, probability distribution for x, where we have x goes from 0 to 6, and f of x is 0 0.1, 0 0.2, 0 0.1, 0 0.3, 0 0.1, 0 0.2. Now let's look at some examples here. We can start with example A, where it says find the probability of x is equal to 2. We know that is just 0 0.1. B is find the probability of x less than or equal to 2. That is the probability of x equals 0 plus the probability of x equals 1 plus the probability of x equals 2, which is, 0 0.1 plus 0 0.2 plus 0 0.1, which is 0 0.4. Now we can go on to C, where it says find the probability of x less than 2, which is equal to the probability of x equals 0 plus the probability of x equals 1, which is 0 0.1 plus 0 0.2, which is equal to 0 0.3. Or you can do it the other way, where its probability of x greater than 3 is equal to 1 minus the probability of x less than or equal to 3, which is the same thing as probability of 1 minus f of 3, which is 1 minus 0 0.7, which is 0 0.3. Now we can move on to D. Oh yeah, we could look at this from the last example. Yes, at the piecewise function. Now D is asking for probability of x greater than 3, which is probability of x equals 4 plus the probability of x equals 6, which is 0 0.1 plus 0 0.2, which is 0 0.3. Or you can do this the other way, where you can find the probability of x greater than 3, which is equal to the probability of 1 minus less than or equal to 3, which is the same thing, 1 minus 0 0.7, which would give you 0 0.3. Now I can move on to part E, where it says find the probability of 2 less than or equal to x less than or equal to 4, which is the probability of x is equal to 2 plus the probability of x equals 3 plus the probability of x equals 4. Now from the last graph we can see that it is 0 0.5. Or you can find the probability of x less than or equal to 4 minus the probability of x less than 2. Keep in mind that it is not less than or equal to. That is a key note. Know that it's not less than or equal to 2. If we continue on, we would get f of 4 minus f of 1, which is equal to 0 0.8 minus 0 0.3, which is 0 0.5. So now we can move on to example 13. If the mgf of x is m of t is equal to e to the power of t times 3 over 6 plus e to the power of 2t times 2 over 6 plus e to the power of 3t times 1 over 6 from negative infinity to infinity, we gotta find the following. So we can start with the first one, where it's the PMF of x, but before we do that, we gotta rewrite m of t is equal to the summation of e to the power of tx times f of x, which we know that x is from 1, 2, and 3, and the f of x is basically 3/6, 2/6, and 1/6. Now using that information, we can write the PMF of x, where the x is just 1, 2, and 3, and the f of x is 1/2, 1/3, and 1/6 simplified. Now we can move on to the mean. The mean is basically the expected value of x, which is mu prime, which we gotta take the derivative. So derivative of the derivative. The first derivative is e to the power of t times 1/2 plus 2 times e to the power of 2t times 1/3 plus 3e to the 3t times 1/6. Remember, we got to do the derivative. And so the expected value of x is basically mu prime of 0. So if you plug in 0 for t, you would get 1/2 plus 2 times 1/3 plus 3 times 1/6, which is 1/2 plus 2/3 plus 1/2, which is equal to 5/3. Now we can move on to the variance. So with this in mind, the variance, we can find the mu double prime, which is doing the derivative twice. So you'd get e to the power of t times 1/2 plus 4 times e to the power of 2t times 1/3 plus 9e to the power of 3t times 1/6. Remember, this is the second derivative. So if you just plug in 0 for t, you would just get 1/2 plus 4/3 plus 9/6. And if you add them all up, you get 3 plus 8 plus 9/6 with this common square root, or common denominator, and you get 20/6, which is equal to 3 1/3. This is our expected value of x squared. Now we can see that the variance of that is expected value of x squared minus expected value of x all squared. So we can see from the last problem that our expected value is 3 1/3. Yep, 3 1/3 minus 5/2 squared, which is 20/6 simplified. And the answer is 0.556. Now we can find the expected value of x to the third, which is just derivative 3 times, or one more derivative from the second one, which is expected value of t times 1/2 plus 8 times e to the 2t times 1/3 plus 27e to the power of 3t times 1/6. And that would give you, if you just plug in 0 for t, that would give you 1/2 plus 8/3 plus 27/6. Okay. Common denominator, so we get 3 plus 16/27/6, which would give you 46/6. And if we put that in decimal form, that will give you 7.667.